Hi, I'm here to talk to you about how at OpenLaws we use Hugo in order to improve accessibility to US law. I want to first talk to you about US law in general, the data behind it, and some of the business problems that are associated with it. Next, I want to talk about the technical challenges and some of our solutions to those. And finally, if you have a lot of data or content to publish like we do, hopefully our lessons learned will help you as well. A bit of introduction first. My name is John. I've worked for Fortune 500s, but I've spent most of my career at startups. A few years ago, some engineers and I started a technical consultancy named Kind. And now we still work for startups, but we also work in the US federal government. We work on big problems, impactful ones, and we solve things like trying to tell veterans about what benefits they have. We work on technical strategy at Medicare. We work on the first digital exhibition for the Smithsonian. But it was actually our work in legal tech where we discovered that laws were not as accessible as we would expect them to be in our country. The data is really hard to find, it's really hard to work with. A lot of the websites that the law was published on weren't even searchable, and a lot of the law data was in PDFs and formats that are really inaccessible to people. And so we formed a company called OpenLaws, with the intent that we wanted to be able to provide free access to the laws and regulations of this country, but really be able to help people find the laws that affect them on a day-to-day basis. And for folks that needed to build things like us, we really wanted to create a really good data set for people to use in order to build applications that use law data. A good example of it would be just the application of generative AI, where some AI is actually using data that is years old. So we want to be able to help with challenges like that, but really ultimately, we want to be able to make something that belongs to everyone, the law, accessible and findable and just more usable for everyone overall. So first, I want to give a simple primer to just law data in general. So I'm not trying to make you an attorney here, but it's helpful to have this context. In our country, there's the federal government, which has its own set of laws, as well as 53 different jurisdictions. So we have Washington, D.C., the 50 states, Puerto Rico, U.S. Virgin Islands, and Guam. Now, if you're a child of the 80s like me, you've seen this guy before. It's a bill, and he eventually becomes a law. He becomes a statute. And so the U.S. Congress passes laws, the president signs it, and then it becomes a statute for the country. Each individual state has its own legislature. They also pass statutes. There's the US Constitution, as well as each individual state constitution. And then there's the rules and regulations. These are laws that are made by agencies within each of the individual states or agencies in the executive branch at the US government level. And these are to implement statutes. There's also case law, which is judicial or court decisions that also have the power of law. And then more obscure are administrative laws. So these are precise technical rules that become procedures in order for the government to operate. They're a little bit harder to find, a little bit more obscure for most of people. So what's the problem here? As I said, the law is scattered across many, many different websites. There are companies that work in this data. However, there's only 2 companies, and these companies focus on legal research and primarily products for law firms and attorneys, so people that have the money to be able to pay for this. Because there's 50 states, there's not exactly a lot of collaboration between these states when they're working with law data. So we're never really going to get one centralized government source for laws. State governments and budgets are very limited. Law is still very much paper-based, so you see a lot of Word documents, PDFs, and actually physical paper as well. There's not a lot of innovation in this space. So as I said, there's only 2 companies in here, and the governments have limited state budgets. And then there's a lack of standards and APIs. There have been a lot of attempts at this, and they are seeing some success, which we're happy about, but that's primarily at the federal level. And so as a result, laws are really hard to access if you're just an average person and not an attorney that's paying for one of these tools. Even for professionals, human beings can access this data, but it's very difficult to pull this data into tools, which becomes a challenge if you work for a legal tech company or you just generally need to work with law data. So one kind of sad example of this, of all these things put together, is that Puerto Rico's statutes website returned to 404 for most of the pandemic. And that was really unfortunate for the folks that lived there. Companies and software don't operate in a vacuum. We have to be able to solve people's problems in order to survive as a startup. And so it's helpful to talk a little bit about our priorities as we design the software that I'm about to talk about. Our primary focus is to be able to iterate. We have to be able to figure out what's working for people, what's not working for people. We also need to automate things so that we can operate more efficiently than the large companies that we compete against. Our data needs to be top-notch. Our quality of the data has to be better than anything else that's out there. And as I said at the beginning, accessibility, readability, and the usability of the data is really the main challenge here. And so we're putting a lot of effort into that. Because we're a startup and we're offering a free product, hosting costs and bandwidth costs are actually top of mind. We're putting something out there that has 4 million pages, so even just getting spidered has actually a cost to us. And finally, we're a bread and butter engineering company, and so we wanted to really create a website that feels very, very responsive and a search that helps you find the things that you need to find. That's one of the main core deficiencies that we really see in the market today. Our first technical challenge is that law data can't easily be represented relationally. It's actually hierarchical, meaning sections of laws contain other sections of laws, which contain more sections of laws. And then this hierarchy also differs for every law jurisdiction. In fact, it's often different across different agencies in the same state. Luckily for us, though, law data looks a lot like nested file folders. There's some additional benefits here too, because file systems are really good at certain things. Because Hugo relies on a file system to store its content, we can store rich text, we can store versioning as different files, we can store images and attachments and other files that go along with the laws. There's a couple other interesting characteristics about law data that are worth mentioning as well. Laws have start and end dates, so they're called effective dates or repeal dates. Also, laws are very read intensive in our case, and the laws actually change fairly slowly. The second technical challenge is that individual pieces of law data are unstructured. On the screen is an example of a law from a website. You can see that we've labeled a couple of things that are relevant to this law. So there's an identifier, and there's a name, and there's text. But it's just text. There are a couple of things that are hints that we can start to derive the law's meaning. So there's indentations, and there's bolded font and italicized font. But really, it's just a wall of text. Here's a second example. This time it's a PDF from Hawaii from the mid-90s. You could actually see a literal rubber stamp in the middle of the document there with the date where the law became effective. In this case, this isn't really a document. This is actually a scanned image. So there's actually no text layer. So we need to derive the structured data from this image. How we actually collect the data and parse the data is outside the scope of this talk. But once we actually are able to capture the structured data, Markdown does a really good job of storing the metadata on this file, the formatting obviously, but we also can use shortcodes and Hugo Markdown CSS attributes in order to style and actually add meaning to this data. So what you see on the screen now is standardized structured content that we create for all of the law sources that we have. On the top, you see front matter, just like you would see for any Hugo Markdown content. And then the bottom, you see valid Markdown. However, in our case, we make heavy use of a couple of things. Numbered and ordered lists. We also use shortcodes in order to add additional metadata into the document. And then we also use CSS attributes via the Hugo Attributes extension in order to add additional meaning and additional display for our bullet points. And on the right, you can see what that same document looks like after Hugo renders it. And this final challenge is actually probably where our technical talk really begins. How does one publish over 4 million pieces of law and still maintain enough flexibility to change the product and not pay a fortune in hosting costs for a very large free website? As you may have caught earlier, laws have start and end dates. Laws actually change regularly, and that's perfectly normal. They're amended, they're repealed, and we have to capture all that workflow that happens in the real world. So, in the end, we have 4 million pieces of data. That's not even including all the different types of laws. And if we're not careful about how we architect and design the hosting and the search and the API, the hosting and bandwidth costs can be astronomical. And for users of Hugo, we're typically used to maybe seconds or minutes for a very large Hugo site. For 4 million pages, we're talking about hours for a particular build. So reviewing what we know, there's 130 laws that change independently. The laws are composed of hierarchical data. That means each law can be divided into a subtree of content. We have a problem that we describe as embarrassingly parallel. In case you're wondering, I left you a Wikipedia link to it. There are multiple opportunities to do things simultaneously and horizontally scale the build process, so it's sort of like a MapReduce for a Hugo build. We can also take advantage of two other opportunities. JavaScript and CSS can be pre-compiled as an initial step, and then we pass in those files into subsequent builds. And then sitemaps can be merged together using sitemap index files, so you can combine all the sitemaps from each individual build. As hardened consultants who are very used to working with either shoestring startup budgets or government constraints, we use technologies that were pretty boring, ones that were proven and productive and that our team already knew. So we didn't try to go for anything shiny here. Lastly, we focused on repeatable processes. So we started with a manual hacky version, like a bash script, and then eventually we built a CLI tool. We start with manual builds, and then we built an asynchronous job server, and then we created UI and CLI tools for the human beings involved. Before I get into what OpenLaws architecture looks like, I wanted to just compare and contrast to what typically you would see for a Hugo site deployment. So at the top, you have GitHub Pages, fairly straightforward, GitHub Repo, GitHub Actions, GitHub Pages. Towards the bottom, you start getting a little fancy. You have a CMS, you might have a GitHub repo, or some sort of data store, and then you have CI, CD, and then a deployment to either a Netlify or S3 and CloudFront if you're building more of your own pieces. We didn't take this lightly when we started building our own infrastructure. We knew that we were heading down a road with a lot of complexity, but we really felt that getting the additional parallelization and being able to build in a more reasonable time frame was really important to us. Here's a look at OpenLaws' parallel build process. We have our data collection process on the left. We have a whole farm of law spiders that also run in parallel, and they store the data to a Postgres database. Now you'll notice that I said that it was actually pretty difficult to store law data in a relational database, but we actually do that. And we also use an L-tree Postgres extension module that allows us to store the hierarchical data in a way that we're pretty happy with. We have a law management system. Just like a CMS, we have a LMS in this case. And then our slight innovation here is we've actually taken the Goldmark Go module, also added the Hugo attributes extension from the Hugo project, and created a Ruby wrapper so that we can get really accurate common mark previews, meaning we can get real-time previews of the markdown and how that will look in HTML within our law management system in real time. We have a CLI tool that's used in two places. It's used once to trigger the whole build process, but it's also used inside the Docker container in order to trigger the Hugo build using the Hugo binary. After collecting a new set of law data, we then generate markdown from the Postgres database. We use an R2 bucket with Cloudflare. So R2 is the equivalent of S3, but on Cloudflare. The main advantage is that it doesn't have egress fees, so it's a pretty big cost savings to us. We use Fly.io, a cloud provider, in order to spin up ephemeral build machines using their API. And so we'll take a Docker container, spin up a pretty beefy build server, attach a NVMe SSD storage to it, and then download any of the newer code that we need, as well as the markdown files that we need in order to do a build. And we'll store that to a markdown cache on the Docker container. We'll use our CLI tool in order to run the Hugo build, and that will output the HTML as well as a sitemap, which we output to a public folder, and then sync that back to another R2 bucket. Each time this Docker container runs, it's only operating on one subtree of content. So you can see down there, it actually takes a folder from the markdown cache, and then it symlinks it into a subfolder in the Hugo/content folder. And so we have a couple of places where we can parallelize things. We can either run multiple build servers against multiple laws at the same time, or we can run multiple build machines against and kind of sequentially go through all of the subfolders that we need to build content for. In order to bring everything back together again, we use data JSON files that Hugo takes to build all of the top-level index files in order to reference all these subfolders of content. We pull in the minified CSS, the JavaScript, the gzip sitemaps, and then we generate the sitemap index file that references all those gzip files. We pull those into R2 buckets, into a static asset bucket, as well as a HTML fragment bucket for the laws. And then we get a little bit fancy here. We use Cloudflare Edge functions in order to style some of our sites. The reason we do this is because we need white label versions of the site for customers, but also because we don't want to rebuild all 4 million pages whenever we make a small change to the site. So if we wanted to update the header or the footer, we don't want to have to rebuild 4 million pages. And so Cloudflare provides a really affordable way in order to customize and personalize each individual page, and we take advantage of that. Diving in deeper into what happens on the build machine or our Docker container, we run our CLI tool there, and it takes a couple of parameters. It takes what law we want to build against, what subtree of data that we want to build against, and then a couple of familiar Hugo parameters, base URL and Hugo theme. But it also asks for a JavaScript and CSS file name. So we build these initially when we start building the law, and we pass them into all subsequent builds. And so in the Hugo layout, you can see that it's expecting an environmental variable for the JavaScript and the CSS file name, and then that's configured via the CLI tool. We want to use all the available cores on this Docker container, so our CLI tool detects the number of cores and then sets it accordingly. And then, of course, here's the Hugo production command. So you can see the shell command getting passed in here with the minify flag, and then all the familiar flags that you could pass into a Hugo build. So I acknowledge that this approach has a lot of complexities to it, and it's definitely not the right approach for most people. But I wanted to call out, if you have a lot of content to publish, if your content is nicely subdivided into subtrees of content, if you have enough team members and can handle the complexity and it's worth it in order to get the additional speed, then this might be the right approach for you. So I wanted to call that out. Finally, reviewing some of the things that we've learned along the way, definitely look for things that are embarrassingly parallel in your own domain, and pay attention to what content changes and how frequently it changes. Also, be careful with layout changes that are global, so navs and marketing elements, for example. You can compile CSS and JavaScript once and pass it into each parallel build, and same thing with sitemaps. And just outgrowing GitHub pages or Netlify or Vercel could mean that you have to rebuild a whole lot of functionality. Next, Hugo is really, really fast, but when you have millions of pages, that's still a lot of time. Make sure that you are monitoring your bottlenecks while you're building and make full use of all the cores that you have on the build machine. 16 core VMs are pretty expensive if you run them all the time, but if you only run them when you build, that actually can save you a decent amount of money. And actually, Apple Silicon is actually a really good way to build. So having maybe an older machine that has 10 cores is actually a pretty good way of building your site. And then all the typical best practices when it comes to software still apply here. You should make sure that your build jobs are restartable and they're idempotent. And you should make sure that you have enough automated testing and uptime monitoring in order to validate that your content is building properly, especially when you have millions of pages and it's impossible to test manually. OpenLaws is very much a work in progress. We'd love to see if Hugo could also take over portions of our JSON API that are backed by Rails today, and also increasing the number of pages we generate when we start to cover historical law pages. If you have any questions, please reach out to me. My Mastodon email address are below. If you need law data, we'd love to chat with you. Please check us out at openlaws.us and tell us about what you want to build. If you have a better approach, we'd love to hear it. We're all here learning together at this conference, and we welcome any new ideas. A special thanks to the Hugo team, the CloudCannon team, and of course our OpenLaws team. I'd also like to extend a special thank you to Patrick Cartledge at UK Government Digital Service and the team at the Victoria and Albert Museum. They wrote a blog post about how they built a site with 1.2 million pages covering the museum's collection. That really inspired us. Thanks for attending, and we'll see you out there.